Look closely at the surface of Mars, and you'll find it's covered in massive, intricate scars. These deep canyons and streamlined channels point to a dynamic history, a time when the red planet might have actually been capable of supporting life. This is an image of the Mare Acidalium quadrangle. The curved, streamlined channels here are Martian gullies. Scientists debated how they formed. One theory suggested ancient flowing water, while another proposed sliding chunks of dry ice. This image shows the Ismenias-Lacus quadrangle, degrading into what researchers call brain terrain. This region features maze-like ridges, typically 3 to 5 meters high. Scientists believe these odd formations actually hide ancient ice cores just below the dust. To figure out if these geological anomalies prove that life once existed here, researchers rely on the COLD framework. COLD, or the Confidence of Life Detection Scale, is a rigorous standard used to verify potential biosignatures before any major scientific announcement is made. Identifying these exact geological features, specifically the locations of hidden ice cores, determines the landing sites for future human colonists. Accessing these local water sources is the primary requirement for establishing a base that can survive without constant resupply from Earth. While planetary geologists carefully map out ancient riverbeds, the commercial space sector is moving at a completely different speed. Private companies are actively testing heavy-lift launch vehicles, focusing their massive engineering and financial resources on building the actual transport hardware. This aggressive push has led to some incredibly tight, headline-grabbing timelines. Leaders in the private sector, like Elon Musk, have publicly targeted sending the first Starship missions to Mars as early as 2026. Building a rocket capable of reaching another planet solves the transportation problem. It does not solve the survival problem. Mars is a hostile, freezing vacuum, and keeping humans alive upon arrival requires an entirely separate, massive logistical effort. Surviving Mars requires a meticulously phased, multi-decade robotic infrastructure plan. This strategy prioritizes the construction of functional life support and power systems over the mere delivery of heavy-lift transport hardware. NASA has drafted a comprehensive master plan specifically designed to systematically pave the way for human arrival over the next 2 decades. This chart outlines the Exploring Mars Together strategy. Instead of a single rushed sprint, it treats the planet as a highly scheduled, phased construction site. Looking at the top row, the immediate priority through the early 2030s is the Mars Sample Return mission. Rovers currently operating on the surface are incredible machines, but their onboard instruments are naturally limited by physical size and power. To fully understand Mars' dynamic history, scientists need to study the chemical makeup of these rocks using full-scale Earth-based laboratories. Bringing physical samples back to Earth is a mandatory prerequisite. Analyzing that soil tells us exactly what kinds of chemical and geological hazards our future astronauts are going to be walking into. In the 2030s, NASA's focus directly transitions to building the permanent orbital and surface network required for a sustained presence. This diagram shows the deployment of high-altitude payloads and orbital relay tugs. NASA plans to establish a continuous communication grid to ensure a reliable, high-bandwidth data stream between Earth and specific locations on the Martian surface. Simultaneously, a buildup happens on the ground. Engineers are developing advanced astrobiology rovers equipped with complex subsurface access technologies, requiring extreme precision and heavy-duty mechanics. These specific heavy-duty subsurface tools are actively designed to drill deep into that maze-like brain terrain we discussed earlier. Reaching those ancient ice cores provides a localized, secure water supply that can be tapped and processed. By the end of the 2030s, this robotic vanguard completes its work. Mars transitions from an isolated frontier into a fully networked, resource-mapped outpost that is actively ready to support human habitation. This brings us to the far right of the timeline. Crossing into the 2040s marks the monumental transition away from robotic infrastructure scaffolding and into actual human arrival. Decades of sample returns, established communication grids, and precisely mapped ice cores drastically de-risk that initial landing sequence. The crew isn't flying blind, they're arriving at a prepared site. These 2040s missions aim to establish a permanent, self-sustaining settlement, utilizing the local resources and communication hubs mapped by the previous robotic generation. The early colonization phase will be incredibly harsh. every single day, the survival of the crew will rely entirely on the integrity of the power and life support infrastructure laid down by the robots that got there first. Putting boots in the Martian dust is a historic triumph, yet establishing that permanent human presence merely sets the stage for a much larger planetary-scale ambition. As these early settlements grow and begin extracting local minerals and gases for fuels, the mission parameters expand toward the ultimate long-term ambition: terraforming. This diagram outlines the core requirements for terraforming, a planetary engineering project requiring extreme, resource-intensive initiatives to actively thicken the atmosphere, increase the pressure, and warm the climate. Creating a world that can sustainably host unprotected life is a distant, centuries-long dream, but mathematically and scientifically, it represents the logical endpoint of the blueprint we are drafting today. The data from current sample returns and the hardware tests of the orbital relays provide the mandatory foundation for this future work. Each successful robotic landing brings the physics of atmosphere modification closer to reality. The roadmap is already in motion. The exact generation of engineers and scientists who will begin the physical transformation of another world is alive right now.